Okay, now we're going to go over notes on the 4 different angle relationship types that you looked at in the previous activity. The first type is called complementary. This is an example of what complementary angles might look like because complementary angles have a sum of 90 degrees. 90 degrees is also the same as a right angle. Right angles are indicated by the little box in the corner. These two angles are complementary because they have a sum of 90 degrees. One thing you're going to be asked to do in this unit is to write and solve equations to figure out missing angle measures in different types of angle relationships. So, for setting up an equation, this is a how-to. You'll show how to set up an equation to solve for x and unknown angle measures using the picture provided. So, in this picture, we have complementary angles because they have a sum of 90 degrees. To have a sum means to have an answer to an addition problem. So if this angle is x plus 4 and this angle is 3x plus 2, if I add these together and make it equal to 90, that will show complementary angles. So x plus 4 plus 3x plus 2 equals 90. These two angles added together equal 90 because they're complementary. Next, everything else we have already learned this year about solving equations. I'm going to first combine like terms. X plus 3x is 4x, 4 plus 2 is 6, 4x plus 6 equals 90. Subtract 6 from both sides, divide by 4 on both sides. X equals 21. Okay, that is the value of x. That is not the value of the unknown angle. The last step for this will be to substitute what we know the x value is to figure out unknown angles. So if x is 21, for angle number 1, 21 plus 4 equals 25. X plus 4 equals 25. Angle number 1 is 25 degrees. Angle number 2, 3 times x plus 2 is angle number 2. Therefore, 3 times 21 plus 2 equals 65 degrees. The measure of angle 2 is 65 degrees. Our next angle relationship type is supplementary angles. This is a picture of what supplementary angles might look like. Supplementary angles have a sum of 180 degrees. They also might look like a straight angle. Okay, for setting up an equation and a how-to, you'll show how to set up an equation to solve for x and unknown angle measures using the picture provided. In this picture, notice that this says 3x. Okay, we have 3x is one angle measure, 7x minus 20 is the other angle measure. The sum of these two angles is 180 degrees, so 3x plus 7x minus 20 equals 180. This is my equation. Everything else is prior knowledge that we learned this year. 3x plus 7x is 10x. We still have minus 20. Therefore, 10x minus 20 equals 180. Add 20 to both sides, divide by 10 on both sides, x equals 20. Now that I know that x equals 20, I can get my unknown angle measures. This angle is 3x, so 3 times 20 is 60 degrees. The measure of this angle is 60 degrees. This angle is 7 times x minus 20. So that would be 7 times x, which is 20, minus 20. 7 times 20 minus 20 is 120 degrees, so angle 2's measure is 120 degrees. We also know this is true because 60 plus 120 equals 180. The third type of angle measures is vertical angle measures. Vertical angles are angles that are opposite one another and are formed by intersecting lines. In the example picture, angle A and B are vertical angles. One thing that's important to know is that vertical angles are always congruent, meaning they are equal. So whatever A is, B is the exact same measure. Okay, we're going to show how to set up an equation to solve for x and unknown angle measures using the picture provided. In this picture, these are vertical angles. These are equal to each other. Therefore, 11y minus 36 equals 63. My equation is here. Subtract or add 36 to both sides, divide by 11 on both sides, y equals 9. The value of y is 9. The last step is to figure out missing angle measures. This angle we already knew is 63 degrees, so it has to be 63 degrees. This angle says 11 times y, this should say y, which is 9, minus 36 will give you the angle measure. 11 times 9 minus 36 is 63. The measure of this angle is 63 degrees. We know that's true because they should be equal to each other anyways, since they are vertical angles. The last type is adjacent angles. Adjacent angles have a common